Alright guys, so what we started talking about this week is transformations, and especially transformations of parent functions, and we're still talking about domain and range with all of this, so please don't forget your domain and range and all the other things that we've talked about, because here coming up at the end of the 6 weeks, we're going to have our 6 weeks test. So what we're looking at here is not exactly a parent function, it's really just a random graph. So all of this that we're about to do is predicated on this random graph that we're looking at. And so the first thing that we want to do is just kind of identify what the table of this graph looks like. And so that's why I'm looking at f of -2. And so I go to -2 for my x value, and I see where my y is for it. And I see that it's at 1. And then I go to -1, and I see that my y value is down here at -1 as well. And when x is 0, my y is 2. When my x is 1, my y is also 1. When my x is 2, I come up here and I see that my y value is 3, and that at 3, my y value is 0. And so I can just plug these right here into my table. And so everything that we're about to do from here on out is going to be based on this table. So this equation right here, and so this equation right here will also be predicated on this table right here. So let's go ahead and jump right into this f of x plus 2. So the first thing I want to just share with you guys is this f of is really just any basic function. So like when we talk about, say, a quadratic, the way it could look would be like x plus 2 squared, and then this one would be something like, say, x minus 2 squared. Or if we were talking about absolute value, it would look like this, the absolute value of x minus 2. Or if we were talking about the square root, it would be the square root of x minus 2. So this f is just kind of a general function notation for whatever we're talking about. So that's usually the most confusing part about all of this, is that I'm not really quite sure what the f means. And so the function of x plus 2 is really just a generalized format. So as we look at this, and we want to kind of see what happens when I change my values at x of -4, -3, -2, -1, 0, 1, and 2. And so all I'm going to do is just plug in the number that I see. So like here I have -4 plus 2, which gives me a value of f of -2. And if we recall up here, f of -2 was just the value of 1. And so I'll put my 1 there. Then I come back and I do it again, only this time, let me make it a little smaller. Alright, so instead of -4, I'm going to use the next number, which is -3. And -3 plus 2 gives me a value of -1. And -1 was -1 for my y value. And so as you do these, you should start noticing that basically the numbers that we have in here, -2, gives me a value of, forgot to erase that one, 0, which gives me a value at +2. And so as I'm going through these, yep, gives me a value of 2. Okay, so then do it again, only this time let me actually erase all of them. So then here I got -1. -1 plus 2 gives me a value of 1. And so I come back here, I look at 1, and that told me that I have it at 1. And if I do 0, so 0 plus 2, see, I'm replacing the x value with what I have. So 0 plus 2 gives me f of 2, and f of 2 gave me a value of 3. And the last one, I'm going to do 1. So this one right here, 1 plus 2 gives me 3. F of 3 was 0. So what I'm going to do is I'm going to go ahead and plot all my points. And let's see, I've got at negative 4, so 1, 2, 3, 4. I've got positive 1. At 3, I've got negative 1. At negative 2, I've got positive 2. Then at negative 1, I have positive 1. At 0, I have 3. And then at 1, I have 0. And so connecting my lines, I get the exact same thing that I have up here. The only difference is that this has been shifted to the left 2 units. So on this next one, I want you guys to try this one out and see what you come up with, and I want you to tell me which way this shifts and what it does. Alright, so on this next one, please notice that now we have the plus 2 on the outside of the function. And so remember we had some parent functions like, say, quadratic again. So this would be an example of this would be something like x squared plus 2, or x cubed plus 2, or ln of x plus 2, or the absolute value of x plus 2. Notice everywhere I'm putting my parent function, these circled ones being the parent function, on the outside of it, what is happening? You got the plus 2 happening. And so that's how this is going to relate back to what we're doing here. And so what we want to know is what happens when I do add 2 to the outside of this. Well, so the first thing I do is I look at what I've got going on. So f of, and again, x in this first case is negative 2 plus 2. And what was the value of f of negative 2? And we find out that the value was 1. And so then I'm just going to add 2 to it. And so 1 plus 2 gives me 3. And so again, I'll go through here and I will keep the plus 2 right here the same. That way, let me change colors too, just so everybody can kind of see. Negative 1 is right here for the next one, and f of negative 1 was also negative 1. And so 2 minus 1 gives me 1. And then I just keep going through the line and replace what it is that I have. So 0, and f of 0, I come back, f of 0 gave me 2, and 2 plus 2 gives me a total of 4. Alright, let me erase those again. And then negative, so I put 1 in there. F of 1 gave me also positive 1, and so 1 plus 2 is 3. And then, as you can notice, what's basically happening here is the next one is going to be f of 2. F of 2 gave me 3, and so 3 plus 2 gives me 5. And f of 3, the value was 0, and 0 plus 2 is 0. So I'm going to go ahead and plot my points again. So negative 2, negative 2 and positive 3, negative 1 and positive 1, 0 and 4, so 2, 3, 4, 1 and 3, 2 and 5. Alright, so 2 and 5, 1, 2, 3, 4, 5, and then 3 and 2. So then, as I connect my dots again, you'll notice that this graph looks identical to this graph, with the only difference being that this was shifted up a total of 2 units. So what we can do is every time I see that I have a function with plus 2 on the outside of it, I know that I'm going to shift up 2 units. So how did the table change? We added 2 to each value, and how did the graph itself change? It shifted up 2 units. So just as relating this back to our parent functions, when I had the x squared plus 2, because it's outside, I know that it shifts up 2 units. Whereas, remember we did this one, x plus 2, like this, with the parentheses around the x and the 2, that shifted to the left 2 units. So one of the big differences that you need to start noticing is what is happening when I have a value outside of the x and when I have a value inside of the x. And so, yeah. Alright, so the last one that I want you guys to work on today is the negative. And we looked at the negatives also a little bit yesterday, and again, the f of x is just like any function that I can think of. So just taking some examples of parent functions, I could have negative absolute value of x, or negative x squared, or negative x cubed, or negative ln, or negative e to the x, any of the parent functions. Basically the negative is going to be on the outside. That's what this f of x is kind of referring to, is just any of the functions that we know about. So absolute value, quadratic, cubic, logarithmic, and so forth. So keep that in mind, that while we're doing these, the f of x is just a generalized format. So again, I'm just going to look at this and say negative parentheses f of, and then depending on what the x value is, so in this case negative 2 is going to equal negative times whatever the value of f of negative 2 was, which in this case was 1. So negative 1. And so I'll go again, just going through the list of my x values, and again here I'll use a blue. So negative 1 gave me a value of negative 1, negative negative gave me positive, and 0, f of 0 was a value of 2, so negative 2 will be my answer here. F of 1 had a total value of 1, so again, negative 1. And then let's see, f of 2 gave me a value of 3, so negative 3. And then lastly, f of 3 was a value of 0, and negative 0 is neither positive or negative, so I just leave it at that. And so then I go ahead and plot my points. So negative 2, negative 1, negative 1, positive 1, 0, negative 2, 1, negative 1, 2, negative 3, and then 3 to 0. And so then again I connect my dots. Now this doesn't look very alike to this immediately, but if you'll notice, if you take your graph and put it up against it, you'll notice that it's basically flipped completely from what I have here. So this is just a reflection over, now let me put this in here correctly, there we go. Alright, so this is just a reflection over the x-axis. So anytime you see something like this, we know that the table changed by, we multiplied our y values by negative 1, and the graph changed by reflecting over the x-axis in this case. And so go ahead and try the other problem out that looks like this, f of negative x, and see what you discover with that. And so coming back to just real quickly with this negative function, so if I have negative x squared, that means that I'm transforming my parent function to do what? To go flipped down to the other axis. Or another example of that would be if I took the, let's say the absolute value of x, which remember is the v, right? And so if I do a negative in front of that, I know that it flips it to a downward facing v. So if you guys remember the video, the music video, it talked about making the negative in front of the absolute value, made it flip around. That's what we're talking about now. So let's go ahead and see what we can take care of today, and we'll go ahead and talk a little bit more about this. I know there's a couple more problems in here, but we'll address those later on.